Assalamualaikum warahmatullahi taala wabarakatuh. For today class, so we will start now. So for today class we will continue on designing a reinforced concrete foundation. So before that, as usual, you are required to fill up your attendance. Okay, so for this time you just have to fill up your attendance once only. Okay, so please make sure you answer all the questions. So I allow you to fill up the attendance at the end of the class. So I'll give you a time for you to fill up the attendance, and then after you fill up the attendance you may leave the class. So for today class we'll continue on designing a foundation. Okay, so if you have any question, as usual, you may chat me at the chat box, and also you may on your microphone, and then you may ask the question. So if you don't understand anything, okay. So here is a reinforced concrete foundation design. So what we are going to do here, at the end of this class, you should be able to determine the load on the foundation that we transfer, okay, from the superstructure. Second one, you should be able to determine the types of foundation that you're going to design, and then understand to determine the design parameters, and able to design reinforced concrete foundation, and then you know how it's function in your reinforced concrete design. So each of the element have their own function, then you have to know, and then each of the element in reinforced concrete structure is connected between each other. So when you miscalculation in any of the design steps, so you may have a problem connecting to each of the structural elements. So I hope that you really understand how to transfer the load from the slab to the beam, from the beam to the column to the foundation, so that your design is accurate and less miscellaneous. Okay, so this is the content of our presentation today, or my class today, which is on types of foundation selection, design specification, and also foundation design. So we go through on the types of the foundation. So we have a lot types of foundation. As you can see in my slide here, okay, there is a shallow foundation and also deep foundation. So for the shallow foundation, we have, for example, is strip footing, okay, and then this is a deep strip footing. We have here a pad footing. Okay, here is a pad footing, simple spread footing. Okay, and then we have a slope footing. Okay, we have a rough footing. Okay, and then we have a few other types. Okay, this is a pad foundation. So this is your column stump. Okay, before you start your first ground floor. Okay, this is the pile foundation. So normally at the top of the pile foundation, we have a pile cap in order for us to start our superstructure. So this is a type of a foundation. So how we going to choose the foundation that we are going to use for our structure? So there is a few criteria in the foundation selection that we have to follow. So in my case, in your case here, so you have study, you have to know what are the criteria that you have to check in order for you to choose the foundation. Okay, here we go. Okay, in the foundation selection, there is a few steps that you have to know. The first one is the load of structure. So the loading condition coming from the structure is one of the factors that govern foundation selection. It is influenced by the types of building, types of construction material, environmental factor, earthquake susceptibility. So means that, so when you would like to design your foundation, you have to know what are the structure on top of this foundation. So either it is a single story, double story house, bungalow house, multi-story house, so that you will identify the structure load from that particular other element like beam, slab, column, and also gravity load. Another thing is, load of the structure is also come from the additional load like environment coming from is at the area of natural disasters such as an earthquake, volcanics, flood area. So you have to understand this environmental condition so that you will choose the right foundation that you're going to use in order to support your building. Selection of the materials such as brick, stone, steel, and concrete for construction affect the selection of the foundation also, because it will reflect the settlement calculation of the foundation is another factor that associated with load of the structure. So the material that you're going to use for your superstructure is also affected a type of a footing or foundation that you're going to design. So you have to be careful. Okay, and then in case of low rise, for example, shallow foundation is preferred. Okay, however, for high rise, deep foundation like piling, okay, and then board pile, okay, is required. So deep foundation is provided because ground at the greater depth are highly compacted, and also sometimes for a lower soil bearing capacity or lower ground or weak ground, so sometimes we choose deep foundation in order for us to design the foundation for the building. We provide a foundation for the building. Next is the soil bearing capacity. So as usually we know that the soil bearing capacity is important for us to study in foundation design, because this soil bearing capacity is actually a strength, okay, of the soil, and then we have to know the suitability of the foundation based on the soil bearing capacity. So soil bearing capacity is one of the most crucial criteria that affect the selection of the appropriate types of foundation. Decision can be made to choose shallow or deep foundation based on the soil bearing pressure. So you have to check your soil bearing pressure. So after this, I will explain to you how to determine the soil bearing pressure ataupun soil bearing capacity. So in order for you to choose what is actually the suitability of the foundation. For example, if it is a hard soil, normally it's enough for us to have a shallow foundation. As an example here, an allowable bearing pressure of at least 100 kilonewton per meter squared or higher is effective for shallow foundation. So it means that if your area or your soil bearing capacity is with high pressure or high bearing capacity, so you may use a shallow foundation. No need for you to use a deep foundation. So however, higher structure can consider a rough foundation, provided that the modulus of subgrade reaction shall not be exceeded when calculated. So rough foundation is also good for the shallow for the building, okay, that have large area. Okay, for example, if the dimension, okay, of the building, for example, like a slab like this one, okay, so like this one, okay, so for example like this one, okay, so means that on top of this, okay, building, okay, you may have your rough foundation, so that when there is a settlement happen here, so the settlement will occur homogeneously, okay, to the building. Okay, next, for the foundation selection is based on the soil type. So each country or each continent have their own soil type. So, or each area. So you have to study the soil profile at that area based on soil investigation. So there are different types of soil like sandy soil, loose soil, clay soil, and expansive soil. From the surface to a depth of 3 meters is a term as a topsoil, and the subsoil begin after 3 meter depth. So you have to study each layer, what are the most dominant soil at that area. So different types of soil, okay, will give a different soil bearing capacity. Characteristics specifically bearing capacity of both topsoil and subsoil layer will to a great extent control the foundation selection. Okay, for low bearing capacity soil, stronger and suitable foundation shall be selected compared to with case where the soil has strength bearing capacity. So the bearing capacity is the ability of soil to safely support structural load without suffering shear failure and intolerable settlement. So if not, there will be a tilting of the foundation. Okay, if you choose a wrong types of foundation, so there is possibility tilting of the, if for example, if you choose a shallow foundation like a pad foundation, there will be the foundation can be tilting so that the settlement will occur to the building. So next we will go through on each types of soil and then what types of foundation that is suitable for that soil. Okay, so this is the main biomass in the world. Have a different types of soil, so from the different continents. So you may have look and study at a different continent. If you have an opportunity to work at the Middle East country, for example, you may know what are the types of soil over there. So if you have a look here, so this is the Middle East. Most of the Middle East is a desert area. So desert area, what types of soil is it? So so you have to study, and then it's a really dry area. So what are the types of foundation that is suitable for that area? So these maps, okay, can help you to identify what are the types of soil at that area. Okay, so next, okay, still on the foundation selection, we have a look first on the clay soil. Okay, so what are the suitable types of foundation for the clay soil? So the clay soil has a great capacity for water retention. That is why great expansion and shrinkage are expected in this type of soil. As a result, foundation structure can suffer from great settlement and uplift pressure. That is why clay soil is not desirable. Applicable codes such as British Standard recommend minimum depth of 1 meter for foundation and 3 meter if there are trees around. Okay, so means that you have to consider also the surrounding area between these soil types. Okay, so so that you will choose the correct foundation. Okay, normally, okay, rough or matte foundation is the best foundation types to build on the clay soil, and ribs and beam can be incorporated into to increase its stiffness. If rough foundation is costly, imposed load are large. Okay, so it will increase the imposed load. A strong soil layer is not available at shallow foundation, then under ream pile should be selected. So means that, so in order for us to know what are the types of the foundation, we have to study the geographical behavior of that area also. And then in economical factor is also affected the types of the foundation based on the types of soil. Okay, so in this case, for example, if it is too expensive, you may change to pile. Sometimes pile is much more cheaper compared to the shallow foundation like rough foundation. In clay soil also, it is recommended to collect and drain rainwater, extend foundation to a depth where moisture fluctuation does not occur, remove weak and shallow soil layer such as black cotton soil. So we have to remove it first in order for us to avoid any problem happen, so like a settlement and so on. So after we constructed the structure, so execute construction during dry season if possible, and distribute structure load as uniform as possible. So because of we do not want during the wet season, there is possibility of the water can be retained on top of the clay soil. So we would like to avoid that situation so that it become a problem when we would like to construct the foundation in the clay soil. So in that case where a shallow firm soil layer covers soft clay soil layer, it is advisable to use wide reinforced straight foundation. So it means that if it is a layer cover soft clay soil. So means that the clay soil have a low bearing capacity compared to the normal clay soil. So we are advisable to use a strip footing. So strip footing, we will have a long strip footing like this figure, okay, so that it will give a full settlement or homogeneous settlement to the building. Okay, next is a pit soil. So pit soil is like if I'm not mistaken, it's like a tanah gambut. Okay, so it is considerable porous, easily compressible, and dark brown or black color soil, which is commonly present near wetland. Okay, it undergoes expansion and shrinkage due to the moisture fluctuation. So extremely weak in terms of load carrying capacity. So means this soil is very weak. Okay, so because it is a loose, high porosity and so on. So we have a look at the figure below here, the different types of pit soil. Okay, at the different countries. So this is at United Kingdom, this is at Malaysia, this is at New Zealand, this is at Canada. So normally, if we have a look also here, so the plant that is growing up on top of this pit soil is actually is a very like a bush. Okay, not a very not a pokok-pokok yang besar such as a forest and so on. Okay, so because the soil is very loose and very porous, have a very low soil bearing capacity, so it should be either remove strong strata and strip foundation is a good option in this case. So if the thickness of pit soil is great and its removal is not economical, then other foundation type should be selected. So sometimes when we have this weak soil, sometimes we have to remove it first so that we can do a soil improvement for that area. So in order for us to increase the soil bearing capacity, then we start our foundation work. So it means that the earthwork process is much more important, so that we can increase the soil bearing capacity. So for instance, concrete pile extended to the firm soil layer below, pad and beam foundation took to firm strata below for small project, or rough foundation for the case where firm strata are not available at reasonable depth, but there is hard surface crust with 3 to 4 meter thick of suitable bearing capacity. So this is how that we can increase the soil bearing capacity or the performance of the soil for the pit soil. Okay, this is a silt. So silty soil, which is smooth to touch, is generally not suitable for foundation structure because of its expansion, which exert pressure against foundation and damage. So there's possibility it will cause a problem to the structure. So if we have a silt types of soil, try to avoid to construct the structure, okay, at this zone or this area. So if we would like to construct a structure at this area, so there is a few consideration. Okay, the silt retain moisture. So when it's retain moisture, there is possibility seepage with high water table, and the water is retained in the soil. Okay, then there is possibility is not easily to drain it off. Okay, reinforced concrete spread and isolated footing are appropriate if silt or silty clay is stiff. Okay, if it is stiff and extend to a great depth. The depth of foundation should be greater than the zone of the erosion and the zone of swelling and shrinkage. So means that the depth of this foundation should be high. Okay, so means that normally if it's 3 meter, it's have to go beyond that. Okay, so it's you have to do the soil investigation. Okay, so that you will know each of the layer performance of the soil. Okay, sand and gravel. So for the sand and gravel, allow water drainage that is wide, do not cause structural movement. Moist compaction of soil and sand make good support for the foundation. So it based on the soil is based with the soil and also sand, gravel and also sand. Okay, so when it is compacted, it will increase, okay, the soil bearing capacity. So it is good for us to have these types of soil to construct a shallow foundation. So dry compacted gravel and sand subsoil are adequate for spread and straight footing. Okay, generally a depth 700 millimeter is acceptable. So no need to be height like until 3 meters, okay, 1 meters, okay, as long as the ground has adequate bearing capacity. So again, we have to check the soil bearing capacity. So if gravel is submerged in the water, the bearing capacity is declined by half. So it means that it reduced half. So if it is submerged in the water, that is why it is important to keep the foundation as high as possible. So in this case, so we have to increase the height of the foundation. A shallow reinforced widespread foundation may be suitable. So sand hold together reasonably well when damp, compacted, and uniform. But trenches, okay, may collapse, and so sheet pile is often used to retain. So it means that, so when we would like to construct this straight footing by using these types of soil, so normally we will have a trench. Trench is like a small parade, okay, parade, okay. So that is a trench. So in order for us to avoid the trench from collapse, so we have to do a sheet pile. Sheet pile is actually a steel pile. So we have to retain, dia jadi macam tembok penahan, okay. So retaining structure, okay, to the soil so that the soil will not collapse. Okay, if loose sand is extended for the great depth, then it is recommended to compact it and use spread footing. Alternatively, rough or driven pile, augured pile, or cast in place pile, or cast in situ pile, or board pile can be selected without the use of compaction energy. Okay, so next is the rock. Okay, generally rocks such as limestone, bedrock, and sandstone have substantially high bearing capacity. This makes it suitable for supporting foundation of a commercial and residential building. So it's enough for us to have a shallow foundation. Okay, like a rough footing, street footing, okay, pad footing. Okay, loam is the best option to support foundation because of its uniformly balanced characteristic. So when there is a settlement, there is possibility the settlement will occur homogeneously. Okay, so it will not cause a problem to the structure from cracking and so on. So it's maintain water at a balanced rate and hence neither shrink or expand to an extent that damage foundation. Loam is a combination of clay, silt, sand, and dark in color and soft, dry and crumbly to the touch. Okay, isolated footing, okay, is the most desirable types of foundation for the loam soil. The depth and area of the foundation is depend on the bearing capacity also, and then depth of the groundwater table and depth of the load bearing stratum. Okay, so whatever it is, basic in a foundation selection, we have to do soil investigation to know the layer of the soil that is located at that area of project of the site project, so that we will determine the right foundation. Okay, next is previously used soil. So means that for example, we would like to use area that has been used for other purpose. Okay, for example, is tempat pembuangan sampah. Okay, we would like to construct the building on top of that area so that there is maybe a contamination, the obstruction. Okay, for example, it is a mining area, so tanah lombong dan sebagainya. So that you have to know, you have to take into consideration when you selected the foundation. So if for instance loose sand extend to a large depth, then rough foundation can be selected to evenly distributed the load, and the pile foundation will be required for heavy structure such as multi-story building. So if you would like to construct a building at this use soil, okay, so further investigation is much more needed, okay, compared to a normal soil that has not been touched before this. Okay, so the soil investigations is much more complicated. So the soil improvement is much more complicated. So you have to know how to do this process during you like to start your construction. Next is a mountain soil and also forest soil. Mountain soil and forest soil, okay, are mostly like to have boulders at various depth. Boulders is like a batu yang besar, so means that they will be used as a base, okay, for your foundation. So pile foundation are not suitable for residential building. With one or two floor isolated reinforced pad foundation are suitable. For single story building, reinforced concrete straight foundation are suitable. Okay. Okay, this is an additional information. Actually, I found it by myself. Okay, so nowadays we see that a lot of reclamation land, right? So in Penang itself, okay, we do already have a lot of project on top of reclamation land. Contohnya at the Geni, okay, at the Geni Drive area, okay, nearby the Penang first Penang Bridge. So if you have a look the new houses area, I can't remember the name of the place, okay, yang ada rumah-rumah baru dekat dengan exit to the Georgetown. Okay, so all this area is actually the reclamation land. So on the reclamation land, so this is a study, okay, by Hisham and Omar 2004. They studied on they were studied on the reclamation land, on the selection of the foundation that is suitable. So on the reclamation land, so there is a few processes that we have to go through in order for us to decide what types of foundation. The first one, we have to know the project description. Second one is the subsurface condition. The third one is soil improvement. The fourth one is a settlement prediction. And then that is a 4 criteria that we have to know. Okay, so for example, in this case, so this is the shallow water area. Okay, this is at Qatar, and then this is the fill up area. Okay, so part of the fill up area. Okay, so in this case, okay, the project involves filling 21 square kilometer of a shallow bay, developing a waterfront reclaimed land for expansion of Doha city. So the bay had a water depth ranging between 0.5 to 1 meter, which is sea water and is a salt water. Okay. Reclamation took place by end tipping from the landward side with no formal compaction procedure. So this is because of this project has been the process, the timeline of the project is quite long. Okay, so the filling material consisted of calcareous sand with gravel and limestone fragment. So we have to identify also what are the filling material that is suitable for the area that we're going to use in order for us to do a reclamation. The procedure adopted during land reclamation was to form an offshore pond by placing fill along the proposed new shoreline. So this is the same. So normally we will fill up the proposed new shoreline. Okay, and then we have to study the subsurface condition. So how to study the subsurface condition? So we have to do the soil investigation. Different phases of subsurface exploration have been conducted before and after the filling completion. So we have to fill the soil, okay, on top of the area that we're going to reclaim, and then we have to do a compaction, and then this is a process of the soil improvement happen. Then we have to do subsurface exploration. So this exploration included test boring and open pits located across the project area. So you have studied this process in geotechnical laboratory. So this is the same process that we have to know. Okay, so the exploration shows that the filling material is underlined by natural seabed deposit that typically consisted of 1 to 1.25 meter layer of plastic silk, followed by an approximately 3.5 meter of sand. The deposit are in turn underlined by an extended layer of weathered limestone that is occasionally intruded by 1 to 2 meter thick layer of weak topographic shell. So means that there is a shell from the sea creatures, okay, at the depth ranging between 24 and 30 meter below the field surface. So it's become already one of the layer, because that is a shore area or the sea area. There is a shell that is already compacted for 1,000 of years, and then it's become a compacted soil, and also it's become a rock. Okay, so this is types of if I'm not mistaken, it's a metamorphic rock or metamorphic rock. So igneous metamorphic rock, I think. Okay, and then soil improvement. So we have to do the soil improvement. So field and laboratory test conducted, which is one of the study is a consolidation test. So this is the original condition. So before the process of filling, so after 12 to 32 years after filling, so then they start the construction. So just imagine how long that we need to make sure that the soil is really stable in order for us to start the construction of that area, so that the soil is really stable and have a specific bearing capacity to construct the structure. So the analysis and then the settlement prediction is also important. So because we're going to construct the building not only for 5 to 10 years, so we have to construct the building for at least 50 years or 100 years. So we have to do a settlement prediction. The analysis deal with the worst possible subsurface layering condition that yield maximum total and differential settlement for low and high rise structure, typically designed for development of the field area. So for a 3-story townhouse as a representative of low structure, isolated footing has been used as a foundation. So it means that at this area, after 23 years of filling, so the soil is very hard, and then the soil bearing capacity is very high. That's why they can use an isolated foundation, which is a pad footing only. So for high-rise structure, settlement of a typical structure, 30 to 50 meter rough foundation resting at the depth of 2.5 meter and imposing a net pressure of 100 kPa was predicted. So sometimes we can have an additional foundation. So if we would like to combine two types of foundation, for example, rough foundation and also piling is also can. So it depends on the situation of that area. There is no specific, although the suggestion is already here on the foundation selection. So sometimes you have to really study, because soil is the earth element that is not easy for us to predict it. Okay, so this is unpredicted element of earth that can change in a few months, in a few days, in a few years. Okay, so we have to study it very well so that it will not cause a problem to our structure. Okay, so next is the ease of the construction. So the choice of foundation should be made keeping in mind the ease of which can be executed and constructed at the site. So the construction of different type of foundation require labor of different skill set and different level of skill. So means that how we going to make sure that the construction is easier, okay, suitable, okay, for that area. Okay, for example, if we would like to construct a building at the hilly side, what are the method that is easily that we can use to construct the foundation at that area. Okay, so is it easy for us to bring all those machinery to that side, okay, if it is a hilly side and so on. So that's why if you have a look, okay, on at Cameron Highland or Genting Highland, so most of the foundation type that they use is a board pile. So one of my former lecturer, okay, at Shah Alam shared their experience okay, at Genting Highland project, so they use a board pile. Okay, board pile, we have two method. So either by human digging, okay, of the soil to the certain depth, up to 30 meters. Okay, sometimes it need oxygen, okay, to digging the foundation, the board pile, okay, the board hole, okay, and then because the machinery cannot be bring over there to boring the hole, okay, so their salary is much more higher compared to uh, normal site, okay, and it's much more higher compared to an engineer. If you would like to do so, you may do so, okay. So next is the water table level. So water table is another significant criteria that affect the foundation selection. So foundation should not be placed on the soil that undergo expansion and contraction due to the water table fluctuation. So it should be construction on fully dry soil or on fully wet soil. So if there is a contoh lah, so contohnya if there is a water table fluctuation, so sometimes okay, this area, okay, sekejap kering, sekejap wet, sekejap kering, sekejap wet, so dia ada expansion, dia ada contraction, okay, so they will give a problem to the soil strength, and then soil bearing capacity can easily drop and increase, okay, it will lose, okay, and then possibility it will cause failure to the structure, a big settlement will occur. So that's why we have to study it carefully. So the water table, okay, we have to check the water table for that area. Okay, if the groundwater table is located below the formation level of the foundation, then shallow foundation is suitable for that area or combined footing. So moreover, for higher water table, rough or mat footing should be, will have an homogeneous settlement, as I said before. This is to counteract uplift pressure and counteract the effect caused by the water, as I said before, to avoid any overturning moment. So this overturning moment is sometimes will cause a structure failure, okay, at the early stage of the construction. If this option cannot be executed, then deep foundation like micro pile or board pile, okay, should be considered to provide the necessary uplift resistance. Okay, so you have any question? So before we go on the next selection of the foundation class, so please don't keep quiet. You may interrupt me during the class. So I'll continue. And then next is adjoining structure, water body slope. So, or slope. Adjoining structure means that there is a structure beside our site. So, slope upper water bodies is like a lake, okay, river, okay, sea, and so on. And then slope is normally at the hilly side. Okay, a parameter that need to be considered for selection of the foundation type. When the foundation of the neighboring structure is very close to the foundation to be construction, it may influence the choice of the safety for the adjoining structure. So, normally, factors such as closeness to a river, lake, natural drain, or vicinity, okay, to a slope should be taken in counting. Isolated reinforced concrete foundation, pad foundation, under still are usually preferred for the building on sloping ground. No residential building should be constructed on slope steeper than 25 degree. Okay, next is a natural disaster. So either it's located at the natural disaster area or not. So we have to know either it is at the extreme weather. So it is, for example, 24 hours at the icy area, okay, or the desert area. So we have to consider all those this condition. Then is economical design. So in terms of safety, workmanship, strength, durability of the foundation. So this economical factor is the most important that we have to know, so that the structure that we're going to construct is really economical for long term. Okay. So next is the design specification. So before that, you have any questions? So please may interrupt me. Don't keep quiet. Okay.
Okay, sir.
Okay, so next is a design specification. The first one is characteristic strength of the concrete, then characteristic strength of the steel, soil bearing capacity, column dimension, design life, exposure class, nominal cover, diameter bar, and also axial load. Okay, so the characteristic strength of the concrete, FCK. So normally we will use at least minimum is 30 MPa, maximum of 40 MPa for the shallow foundation. So for the deep foundation, we can go beyond that. Okay, like LCC itself, they use foundation grade 80 MPa. Okay, steel is same. We have to use a 500 Newton per millimeter square, but it's depend on the availability on the market at each country that we're going to design. So in Malaysia, for example, we are allowed to use 460 based on the market availability. And then the soil bearing capacity. So this is how we can determine the soil bearing capacity using the formula, Terzaghi formula that you has learned in a geotechnical on and also soil mechanics or Hansen formula. And then you may also using the N value based on the SPT N value. So the numbers of blow will reflect the types of soil, either it is soft or hard soil. So it means that if it more than 100 MPa here, which is a stiff soil, so you may use a shallow foundation. Okay, column dimension. So in order for you to determine the column dimension, so we have done before, so I repeat it again. So it's based on the preliminary sizing using span over depth ratio, or you have to follow the fire resistant requirement, and you have to make sure normally your column is flush in the beam so that it will have a good finishing, okay, to your building or your structure. So design life is same. We can use a 50 years, okay, up to 120 years. So normally we use a 50 years. Okay, the exposure class is same what we have done before. So you have to make sure. So for example, okay, if you would like to change the exposure class for your foundation, you may change. So for example, because it is a substructure, substructure is beneath in the soil, okay. So in the soil, so that you have to change sometimes the exposure class. So for example, if it is fully submerged in the water because the water table is high, so the exposure class for the nominal cover so will be different compared to the superstructure. So you have to check the condition of the environmental condition, like the water table, okay, the behavior, the environmental condition, geographical, and so on. Okay. And then the exposure class chosen is same as what we have learned before in the previous lecture. So that is a nominal cover. So for the due to the fire resistance, so we for the nominal cover as usual, you have to check based on three conditions: due to the fire resistance, due to the bond requirement, and due to the exposure class. So due to the fire resistance, so you have to use this table 5.5. Okay. Okay, table 5.5 here. Okay, table 5.5 following the simply supported beam made with a reinforced precise. So you have to follow this table. So not using a slab or using the continuous. Okay. Next, this is a proposed nominal cover. Okay, proposed nominal cover that is made in the national annex, because in the national annex of each country they have their own specification. So for example, in Malaysia here, the expert, okay, the experts already developed this table for us easier to check the minimum requirement of the foundation based on the exposure class. So for example here, so if the grade of the soil, the grade of the concrete that we're going to use for the building is 40 MPa, for example, and glass XD2, the minimum, okay, the minimum foundation, the minimum nominal cover is 30 plus the deviation, which is 10, which is 40 mm. So it's more than that. But for the foundation, okay, we have to follow the requirement. Okay, so I do stated here, okay, for the foundation, based on the Euro code 2, there is a minimum nominal cover here. So the minimum is 50 mm, the maximum is 75 mm. So here is another cases, and here is another cases. Okay, you may check either your proposed C nominal is more than the minimum one or not. Next is the axial load here. So the axial load here is determined from the load transfer from the superstructure that you have calculated before. So the calculation of the permanent action and variable action should be separated and unfactorized, because we will see the use the value in order for us to determine the size of the foundation, and then we have to factorize it again in the foundation design. Okay, so foundation design, types of foundation, we have a shallow foundation and also deep foundation. We have a pad footing and also we have a combined footing. Okay, as what you have learned before. And then we have a deep foundation, which is for pile foundation. So you just need to design a pile cap, not design the piling. Okay, so if you use a pile foundation, so you have to know what is the number of the group pile for that foundation. Okay, based on the pile capacity. For example, each of the pile capacity is 600 MPa. So for example, the load over there is 1000. Okay, so means that you need at least 2 pile. Okay, so 2 pile group. Okay. Okay, any question, class? So before we go on the next example, please answer me.
Sir.
You got any question?
Sir. Hello, sir.
Class, are you here?
Yes, yes.
Diorang nak jawab tanya tu, Sam. Siapa tu?
Sir dengar tak, sir?
Teruskan. Kami dengar.
Sir.
Okay,
Tadi
we will
kan
continue on the next.
Sir.
Saya tak dengar lah.
Sam tak dengar.
Dengar tak, Sam?
Sam dengar.
You can type your question. Okay, wait for a while. Okay, try any of you asking any question. So I can't hear. Okay, again. Okay, Daniel. Okay. Okay.
Sir, dengar, sir?
Yes. Okay.
Sir, yang tadi, okay, kan kita dah design untuk nominal cover kan?
Okay.
Okay, lepas tu kita boleh guna table yang NA2 tu kita untuk check sir?
Yes. So at least we can follow that table, okay, in order for us to check the minimum nominal cover, either is follow the minimum one or not.
Boleh tak sir?
So
Ni
at
saya
least contohnya, okay.
kalau kita just pakai table NA tu saja, boleh tak sir? Ke kita kena
We have to,
kena design
okay.
dulu?
NA2 is based on the exposure class. Okay.
Yes.
So you have to check also based on the fire resistant.
Okay
So
sir.
maksudnya for NA2 for the exposure class, for example, you know the exposure class XC3 for example kan. Okay, so I give you an example here. Okay. Okay, for example, okay. Okay, contoh Okay. Okay, contoh dia, okay. So we have kita punya foundation exposure class is XC3. Okay. So contohnya grade kita pakai grade 40. Okay, grade 40. So means that our minimum nominal cover here is supposed to be 30. Okay, maksudnya C minimum here is 20 mm. Okay. Okay, so untuk fire resistant, okay, kita kena check juga daripada table ni. So either it is fulfill the requirement tak? Okay, contohnya kalau fire resistant kita 1 hour here, okay, so kita punya C minimum is quite big here. Okay, so contohnya 35. Okay, kalau kita punya kita tengok kita punya foundation lah. Okay, so kalau biasanya kalau kita nak terus guna ni pun tak ada masalah, ataupun you have to follow, although the requirement here, okay, is 30 mm, so but you have to follow also the minimum here based on the Eurocode tu. So means that whatever value you provide, okay, contohnya after you calculate the nominal cover, you get the value is 40 mm kan. Okay, so you have to provide following this Eurocode punya requirement. Okay, so means that minimum is 50, maximum is 75. So if you get 60, then okay. Okay, so means that whatever value that you get, the minimum C nominal untuk foundation adalah 50 mm. Okay, faham
Faham sir.
Okay. Any other question?
Saya nak tanya.
Okay.
Macam contoh kan nanti bila kita nak design.
Okay.
Okay, lepas tu NED tu kan kita ambil daripada apa? Daripada column kan. Footing to ground floor.
Yes.
Okay. Sekejap saya kongsi yang movement macam mana rasa?
Tak ada. Kita tak guna moment tu. So kita ambil dia punya NED saja.
Oh, kita ambil NED saja.
Yes, kita ambil NED saja. Okay, from our previous lecture, okay, kan last kali kita ada dia punya axial load kan. Okay. So you ambil that axial load yang without factorize. Sebab tu kan table tu saya dah separatekan yang factorize dengan unfactorized kan. So you ambil yang unfactorized sebab nanti dalam pad footing punya calculation saya akan tunjuk sekejap lagi. So why we have to use that value, daripada mana kita nak akan ambil. Okay. Sekejap lagi saya akan continue on example satu example for pad footing.
Alright.
Okay, ada lagi? Okay, kalau tak ada saya akan go for contoh satu for pad footing. Okay. I will go roughly, okay, on how to start the design only, okay. The further detail of the design tu saya tak akan go through lah, okay, because you already learn how to design. Okay, this is a note from CS522, okay, I won't repeat it again. Okay, cuba saya nak bagi tahu kat sini sahaja. Okay, we would like to start the design here. Okay. So here is the things that I told you. Okay. So we have to separate the GK and also QK here. Okay, because when we would like to determine the size of the footing here, so we have to use 1 GK plus 1 QK. So jangan guna yang 1.35 GK plus 1.5 QK. So where we can get this value, okay, kita boleh dapat daripada, saya buka balik nota daripada column. Okay, dekat column analysis. Okay, yang ini. Okay. So okay, you ambil yang ini, total kan, okay, unfactored ni. Okay, you total up everything unfactored load here. Okay, and then this is for the permanent action. This is for the variable action. You total it up, okay, and then you plus with yang satu lagi exist ini. Okay, and then you will get the total load for the foundation. Boleh faham? Okay, from this table lah. Okay, unfactored. Okay, any other question?
Tak ada, sir.
Tak ada.
Okay, faham eh?
Faham, sir.
Okay, so sekejap. So we go back to the foundation design. Okay, on the foundation design, so I advise you to use shallow foundation lah, okay, pad footing, okay, or combined footing. So you have to design the foundation that is connected to your column that has been designed by you lah. So this is the normal step that we have to go through in order for us to design the foundation. So the first one is the preliminary sizing. Okay, kita tentukan the size. Okay, when you would like to determine the size of the of your foundation, so I advise you to provide a square foundation lah. Okay, the square foundation. So I advise you, okay, to have the size at least in measurable is easy to measure. So 2 meter times 2 meter, 2.5 times 2.5, 3 times 3. Janganlah sampai 2.75, 2.73, okay? So it is advisable to be like that, okay? And then, so after we determine the size, okay, we have to calculate the shear resistance here, okay? And then we have to design here, okay, from the moment, okay, when you would like to provide your reinforcement here, okay, it same for both direction, okay. So the method is like a rectangular section of the beam or same as a slab. So M is equal to M over FCK BD squared. So your B is actually the size of your B lah, okay, not 1 meter. So the actual B for your foundation. Okay, so means that the arrangement will be same for both direction. So if it is a combined footing, the method is different. So you have to design for both direction. Okay, and then you have to check the punching shear. Okay, and then the critical shear check, and then you have to draw the detailing. Okay, so this is an example for the combined footing, okay? So you may have a look. If the combined footing is normally when we have a column, okay, two column that is really near to each other. So if we have a look here, okay, the distance between this column is only about, okay, tengok okay, the distance between this column is only about 1.25 plus around 2 meters, so 3.24 meter. So sometimes the size of the foundation here is 3 meter, 3 meter. So it will clash between each other. So that's why we use a combined footing to connect between these two columns. Okay, so this is how we choose the combined footing as the suitable types of foundation for that particular column. Okay. So you have to, that's why in order for you to make sure that your foundation is not become a combined footing, so you have to make sure the position of your column, so it's quite far from each other, so at least here, okay, at least it's more than 3 meter, okay, so that it will not have a combined footing like this. So for example here, the distance between the center of this column and this column is 3 meter. For example, if you have a one pad footing here, the size is 2 meter, here is 2 meter, it will clash each other at the center here. Okay, so dia dah bersambung dalam 1 meter macam tu. So that's why we are using a combined footing. Okay, so this is a combined footing lah. Okay, you may have a look on this example. So for the cases that you have a combined footing, so you have to check, okay, the nearby location of your foundation. So I believe that most of your foundation is a pad footing because the load for your building is not bigger. Okay, so that I believe that you don't have any problem in order for you to design your foundation. So any question, any other question, class?
Tak ada lagi.
Tak ada lagi, sir.
Okay, so as usual, so for this week task, so you have to submit next week for your foundation design. So the submission will be submit here on the assignment. Okay, sorry. So you have to submit here, okay, in your assignment. So I have a look here. So only 4 of you already turned in your assignment, your reinforced concrete column design. So I hope that any of you that didn't submit yet, so please do submit. So submit as soon as possible, so that you will not have a burden in order for you to complete any other task. So please fill up your attendance, and then I will prepare the next task in the assignment for you to submit next task. Any other question, class?
Tak apa, nanti kami tanya dalam WhatsApp.
Okay, so if there are no any other questions, so that is for our today class. So don't forget to fill up your attendance. So please fill up your attendance first, then you may left this class. So that's it for today. Thank you. Assalamualaikum.